All right, we're going to look at some problems from section 6.5 in our textbook involving logs and applying some of the properties we've learned of logarithms. For questions 1 and 2, we're asked to expand each one. So we're going to apply our log properties, and specifically some of the properties we have going here are power and product. So the first one, in terms of our power, we have 6 times the log of 6 times 5 to the 4th times 7. And now, because we're multiplying, we can apply our product, which is going to give us sums. So we have 6 times the log of 6 plus 6 times the log of 5 to the 4th plus 6 times the log of 7. And then one more power rule here, multiplying 4 times the 6 times the log of 6 plus 24 times the log of 5 plus 6 times the log of 7. And notice we don't write a base there, and that automatically tells us that we are in base 10. Okay, so here we're in base 6. Again, our properties still are the same. So first I would write this as log base 6 of x times y times z times w raised to the 1/2, right? Because square root as a fraction is 1/2. And then applying our power rule, 1/2 the log base 6 of x times y times z times w. And then similar to our previous problem, because we're multiplying, we're going to add. So as we go across, I'm going to write it the log base 6 of x divided by 2, same as multiplying it by 1/2, plus the log base 6 of y over 2, plus the log base 6 of z over 2, and I'm running out a little room here, log base 6 of w over 2. Okay, the next two we're actually condensing, so we're going in the opposite direction. So first thing I'm going to do is apply power here and here. So I have the log base 7 of y plus the log base 7 of z cubed. And dividing by 3 is the same as multiplying by 1/3. So that's plus the log base 7 of x to the 1/3. Okay, so we're adding, so we're going to multiply. So we have the log base 7 of y times z to the 3rd, and I'll write this as the cube root of x. Okay, same here, except now we have a subtraction and mixed in, so that's our quotient rule. So we have power rule a couple of times. So log base 2 of 5 to the 8th plus the log base 2 of 11 to the 8th minus the log base 2 of 6 squared. So again, similar to our other problems, we're all in the same base, so we can apply our log properties. So we're adding, so we can multiply these two. And then because we're subtracting, we're going to divide. And there's our final answer in condensed form. Okay, moving on to a couple of other problems. Here we saw this in our last video as well about using properties and values to find an indicated logarithm, not using our calculator. So I'm going to first apply our quotient rule and write this as log base 7 of 9 minus the log base 7 of 49. And so we look over here and we have 12, 9, and 10. Well, we already have a value, or approximate value at least, for the log base 7 of 9. That's 1.1. And so one of the things that's not listed here, though, is that the log base 7 of 7 is equal to 1. And the reason why that one's important is because notice 49 is 7 squared. And so applying our power rule, similar to what we did before, we have 2 times the log base 7 of 7. And we know that the log base 7 of 7 is 1. So 1.1 minus 2 times 1, 1.1 minus 2, and we get negative 0.9. Okay, and 2 we're going to do, it says approximate each using a calculator. Okay, so we're going to use a couple of different methods here. For the first one, we're going to use change of base. And so this the log base 3 of 2, we can write this as this would be base 10 of 2 divided by base 10 of 3. And so getting our graphing calculators out, right? There's our log, that's base 10 divided, of 2 rather, divided by the log of 3, and the 3 decimal places, we'll write that as 0.631. Now, instead of using log base 10, we can also use natural log. And so we would write this as the natural log of 2 over the natural log of 3. And we should get the same answer. Let's see on our calculators. So we have the ln, or natural log of 2, divided by natural log of 3. And you can see we end up with exactly the same answer. And so technically you can use any base as long as it's the same. And our calculators are programmed for log base 10 and natural log, which is why we generally choose those. I know with some of the newer calculators, when you hit log button, automatically you have a cursor for a base, but I guess this is for a little bit of those older calculators or older students of us. All right, I'm going to show you just one other way to look at this so that you don't always have to worry about a change of base formula. So I'm going to set it equal to x, and I'm going to rewrite this as a exponential equation. So 6 raised to the x is equal to 2.6. And now to get this exponent out of the variable out of the exponent, I'm going to take the natural log of both sides, or we could do the log base 10, either one. Apply our product or power rule rather. So we have x times the natural log of 6 equals the natural log of 2.6. Dividing both sides by the natural log of 6, that would equal 1. And you can see in essence, we're just applying the change of base formula without having to worry specifically about what is the common mistake is which one goes in the numerator, which one goes in the denominator. And we commonly see students who flip it. Well, if you set it equal to x, write it as an exponential, and use logarithms, then you can't go wrong in terms of what's in the numerator, what's in the denominator. So again, here we have natural log of 2.6 divided by the natural log of 6, and we get approximately 0.533. And again, we could have taken the log base 10 of both sides, and you would have ended up with the same answer. Hope that helps, and we'll see you soon.